So what I want to do is to just give a nature-based solution to mitigating and adapting to climate change, which really does scale with the scale of the challenge. And I think we've heard a lot about solutions that may work in smaller areas to limited degrees. But if you really want to make an impact at the global scale, you're going to have to scale up to the global scale. So I'm going to concentrate on the bit that was considered to be the kind of traditional option that we have, conventional management, which is protected areas. But adding that conventionally, we don't protect protected areas from much, and the non-traditional approach to protected areas is to protect them more highly and gain benefits from doing that. So in terms of ecosystem responses to climate change, we can look at a number of properties of populations, communities, ecosystems, which are related to greater resistance and resilience and the ability to rebound from the sorts of disturbances and to cope with the changes that are coming. Those are fairly straightforward, all motherhood and apple pie kind of stuff for ecology. Bigger populations, more reproduction, more mature individuals, etc. Higher levels of connectivity in populations. These are all things that will impart resilience into ecological systems so that they continue to deliver the services and the goods that we rely on. So in terms of how good we can be at building those up, the advantage that we have, should you consider it an advantage, is we've already taken them down a very long way. And in the ocean, we have been busily extracting huge quantities of protein from the sea for a very long time. 200 years of industrial fishing in some parts of the world, in others 100 years or so. But the fact is that across the board, we have lost a huge amount of biodiversity, large animals especially. And we remain in a situation where fisheries management is absent or inadequate across large parts of the globe. So if we can improve on that situation, there is an opportunity to start recovering and restoring things. And in terms of some of those incredibly valuable ecosystems that are providing lots of co-benefits to us, which are not climate related, things like mangroves, kelp, and seagrasses and so on, we have a need to start expanding on the area that has been lost. So in other words, to start rebuilding some of those systems to restore some of the services that we have. So the tool I'm focusing on really is the marine protected areas. And one of the things that marine protected area science tells us very strongly is that you can't just set up a protected area, call it protected, job done, and carry on with business as usual, albeit that is the default approach in many countries. If you really want to gain benefits from those protected areas, you have to protect them from the things that matter. And exploitation is the biggest lever that we've got in terms of changing the situation in the water for a huge number of species. If you stop extracting things, then they can respond pretty quickly. And what you see in those highly protected areas is that there is the opportunity to rebuild populations pretty rapidly, to greatly expand on reproductive output, and to then start building up connectivity with other places by export of offspring from place to place. And so thinking about how you might scale this up to a meaningful level to produce planetary benefits from these naturally restored ecosystems, you really need to start scaling up to large areas of protected area coverage, and way in excess of the current CBD target of 10% of the ocean protected by 2020. And in fact, all of the evidence and models that we have suggest that we need in excess of about 30% of the ocean fully protected in order to really start making a meaningful impact on global level processes. And the science is compatible with even higher levels of protection, still producing net benefits to us. So, the half Earth is very much a live option for protection of the oceans. and bear in mind how limited our opportunities are for managing ecosystems on a very small scale and bit by bit in dealing with these global scale challenges. So really this is all about trying to harness the ability of ecosystems to look after themselves, and by withdrawing threats, focusing on the options that we have for managing, by withdrawing the manageable human threats from them, then we can allow nature to respond in dynamic ways as the conditions change around it. So just to leave you on this note that these systems, by protecting them, will produce both climate change benefits for us, but also it would be worth doing it, even if climate change wasn't happening, to go out and protect the ocean to this level. Thank you.